In between, it's a smoothly
So light bulb, like I said, cool measurement.
They flash the atoms with a laser, whose frequency
Laser. I looked at it. Why do I need to stay motivated? Me? Because I'm staring in the center of the singularity for the standard model. Higgs. Right?
And then immediately drops back down to 1.
I looked at it. I did the thing. It did ones and zeros. It just did speeds on feeds and speeds at this point in time. Now I get that the dude loved it. Now that I've seen that that works, you are in the black hole, buddy.
And the atom would stay dark. But what if the laser hits while the electron is in the middle?
And we'll get into later about decoherence, about input from directory, the client directory, and why it already knows that based on some sensors and stuff about testing, like doing the resistors, getting into the program, the version
like a measurement. And remember,
see him right there. He's right there. I see him. Look at him. He's over here doing stuff. Doing his thing. All right. So this is real simple. Now, for some reason, I figured, okay, A-sharp, viewport. This is the content, the width and height, because that worked for something before in the first position of being a battery, right? Because I got X, Y, and Z, and it does the thing. It emits a magnetic field. It decays on the states of, get up, you come off the screen and do stuff. Apparently I'm stuck in here. Okay, we got buttons. As far as what he is with me in terms of the limits A-sharp viewport, that content inverts on itself for a shadow problem. Why does it end the same way as it starts, and why is the zeros and ones on ones and zeros for a series of steps as you're building this on Word, right? Because this is my first A, and I want to first build A into it, but it already knows things, which is trouble for me. And that goes to say resistors, capacitors, whatever this is, whatever this main heading is, to do the program, and then I want it to do that, do whatever loops it does through standard models of AI chess games, because then they say you want a dictionary. And so all of this became a resistor, a dictionary. It runs through those terms. First it runs this column, then it runs this column, and then minimax some stuff, organize some patterns, is to say photon running through here with all these things here is to actually say, well, it resists, or it goes through so many series of units, and then that clock based on what this is. Because then it says series sets, and that's 1 unit. When units are determined, so it actually moves at a causal speed. I don't know what it'll do. It'll do some stuff up in here, right? And so that's starting to output a physical code on a clock, right? Because I got it to do something, and then it outputted certain volumes on a real basic XYZ, because then that gives me, more than just any kind of sequence of what it does, but there's, I forget what they're called right offhand. But basically, that's the hard line for what this is, as far as I would imagine, or at least why I would want it to build off of that, to loop through all that material by a resistor, capacitor, LED testing kind of a thing, because that's where this kind of stuff gets you to the XY source code. You got X plus Y, or X plus, all right, so AX plus BX equals CX for a basic differential. So when they say, well, the observation of what? Well, A-sharps, I'm looking at, is the light bulb a good version of what the context is for the length and width in this? Sure, we're going to roll with that loop inside here, loop viewport, into what it already knows by these two headings of its first and its end state, because it already ran it, and then it kind of made it a second determination of screens, of being able to click off, and then it kind of said it ran this, and then through its limits, it does another page, because those systems don't really do, or they're not debugged to be able to properly fit on here in some way. And then obviously we get into the app designs, into the bubbles and the clicks and the buttons, right? Because the button's going to correlate to what this really does. I want this home page to open up into an app with a screen on it for control screen, control prompt screen, because that's the output of the app, but it's going to be simpler. It's going to be easier. And so that's what you would design it to do, because that would basically be, again, the combination of, we'll go DOS here, DOS is Word, basically, inside of here about what these standard models are, and a combination. Well, this is the basic sets of rules, right? Ones and zeros on computer chips, what this bit does, and this here is just a resume, or is it a letter, or is it a basic combination of the resistors and zeros and ones to make a test? And I'm good with this version. Not only is this a version, a ROM chip, but then I can get it on the board to do a thing by the basic program, because that testing is the same ones and zero that go into this thing already being done, and the observational laser beams hitting this thing, right? Zod, me and you, buddy, all the way. So, we'll go back here into, we're going to get into sheet and slides. Basically, it's PowerPoint. Basically, it's X, Y, and Z. And I can do this in X, Y, and Z. G1, or G equals the square root of M1, M2. How am I analyzing which bits and bots are doing kind of combinations of codes off of that hardwire circuit through loops, through entirety of their processor. That's where heat equations start to come up later on. Certain numbers of feedback loops and wires next to each other that make other wires not work no more. At least I've seen some of it before. You need shielding and hardening. So this case is like that, shielding and hardening. I just want this one to do it, and we'll do it later. It may not work on any other computer because that algorithm wouldn't output that way, but with some testing, some fancy magic and voodoo, we'll figure this out. So, it just runs. Well, what it runs, by the definition, it hits R in here, because total is a function, and it starts to run R. You have a standard model of sets inside of here, really, that do the basic output on mini-maxing game theory to, well, the first click Salty did to me trying to help him with standard models of what's left over to the best option, just one piece of paper being the standard model. There you go, DOS. Into your resume based on a PowerPoint is those numbers and how to present those. What are the schematics on the code for what it's doing and why it's doing it, so I can use this droid or Python or JavaScript or anything I want to do the same laser beam experiment to determine the distance of the galaxies and this distance, why it's ripping away farther, because it's really just ohms that are just pushing through this thing, and there's approximation of the heat on the wire, that wiggly squiggly line inside here. We're not just talking about all those ones, we're talking about actual copper wire having to redo it because it doesn't make it out of cardboard. You can't make a computer out of cardboard, guys. You can put it in a Hadron Collider, but the point you made a Hadron Collider in a paper or cardboard computer to get it in there, maybe if you're sitting in there and dead, you can do whatever you want, but no. Education awards, kind of, well, they're the same thing, really. They are. This one's green, it's close enough. The spectrums, signal, nomad, whatever. Anyways, catch you on the next one.